Great. Morning, everyone. Hope all of you are doing well in this nice, cold Bloemfontein weather. Sorry, while everyone's taking their seats, I just wanted to start because we said to the live link that we're going to start at 9. I see it's already past 9, so sorry, you guys. But I think we'll be starting soon. Just give us 2 more minutes. With the amount of guys that confirmed. But it looks like next time I'll ask an entrance fee because then the guys feel they have something to lose. Then they show up. Because I was worried we have about 20 spaces too little. but all right. So let's hope there's still some guys joining. I just want to say good morning to everyone. Thank you very much for joining us. We really appreciate it. It's our first event here at Vans Lab. So let's hope everything runs smoothly. I also want to welcome the live link. Good day, you guys. Thanks for joining in. I know there's a few of our bigger clients also joining in on the live link. So welcome, you guys. So just a few technical arrangements. If you guys need to go to the bathroom, you can see the window through there. So it's just in this door, turn right, and then right immediately again. And then please just be mindful of smoking. If anyone smokes, it is a lab. It does affect the analysis and stuff. So we have a dedicated area here at the back, at the Briar. Okay. I hope everyone got coffee and some rusks. I'm not going to eat all of this. I see there's still a lot left. So you guys must help me. All right. So just quickly, the program for today. Although we have 2 profs speaking with us today, it's not a lecture. Let's be interactive, ask questions if you do want to. At the live link, the link is interactive. You guys can ask questions as well. We have someone behind the laptop that will read out the question and will answer as we go. But let's keep it interactive. Let's have it a conversation. And Lindy, or first off, JP from Idwala is gonna just start the day for us in the right manner. Then Lindy will give us a quick, brief background on the lab. Then I'm gonna speak a bit of the technology that we use within the lab. And then our big guest speaker that we flew in all the way from the Netherlands, Prof Wim Bastiaanssen, is there at the back. He's gonna talk to us about IRIWatch and the latest technology regarding satellite imagery, and then Prof Leon is gonna talk about the carbon. So that's a new buzzword in agriculture. Everyone's concentrating on the carbons and building up of carbons. So he's going to talk about the measurement, sequestration, and the trading of carbons on the international market. So then we're going to have a lunch. We're going to have a braai, and afterwards we're going to have a more open discussion. So you'll see on the invite that I sent, I said the way forward. If you have any questions for either Lindy, me, or the 2 profs, you're more than welcome to ask. But please corner them while we're eating or at the braai or whatever. Thank you very much, everyone. JB, if you can just start the day for us in the right way. Then Lindy will come up and speak a bit about the lab.
Morning, everybody. From my side, welcome as well. It's really a privilege to be here. And I just want to tell something. I know Leon for, I think, 40 years now. We were just discussing it outside, and we were talking about, when we were students, we used to talk, listen, all the old toppies are standing there. Now we're the old toppies. But thank you. And something else, I must really mention, I think it's going to be a very worthwhile program. I know a little bit of all the work Leon and his guys are doing here. It's really groundbreaking work, pioneering work. And as far as I know, has been read and discussed and experienced in the field. I don't know of anywhere in the world, really, and I'm not exaggerating, where people are working so much on soil physics. And so that's such a subject we've been neglected for so long in South Africa. But anyway, just on a lighter note, the other day, this Afrikaans English thing, I've got a good friend, and he wanted to buy a horse, and he goes to his neighbor. He said, I want to buy a horse. He said, but I can't sell you that horse. I said, why? He said, but it doesn't look so good. But he insisted, they said, okay, but I want the horse. And 2 weeks later, they met again. He told his neighbor, he said, you bugger, you sell me a blind horse. Yeah, but I told you it doesn't look so good. But anyway, let's close our eyes and say thank you for being here. Thank you, our Heavenly Father, being here, saved us on the trip, on difficult roads, through terrible potholes, and all sorts of challenges. Thank you for being having guests from overseas, well-experienced guys, well-knowledged. And thank you that we have the privilege to work in your garden. And please give us a responsibility to treat it as such. Thank you. Amen.
Morning, everyone. Hope everyone's doing well. We have some cold weather here today. We didn't plan it that way, so I hope everybody has their jackets, and if you need anything, just shout. Jennifer and Simmery are there if you do need guidance to the bathrooms or need any assistance with anything. Okay. So I'm Lindy Smit. I'm the directing manager of Van's Lab and a chemical engineer. For those of you that don't know them yet, this is Prof Leon van Rensburg, and he's a senior soil scientist and the founder of Van's Lab. And then we also have Roelof Smit, the marketing manager of Van's Lab. Okay, voicing the soil, listening to the land. That is Van's Lab's slogan. So we are here to assist farmers to help them gain their soil's optimum potential. So we have a fun activity next. Anybody that can decipher that word? I'll give you half a minute. We can put a beer on the table. Anybody want to try? Yes. First try. Well done. Okay, so accuracy, that's what we are all about. I just want to read the definition. The degree to which the result of a measurement, calculation, or specification conforms to the correct value or standard, compared with precision. Okay, a little bit more about us, about Van's Lab. So Van's Lab came out of a 15 years research project from the University of the Free State with Prof Leon van Rensburg, and he discovered that there wasn't many labs that did the type of analysis that he needed for his experiments, and then we started with Van's Lab. So we have been up and running for 5.5 years now, and we are an independent laboratory with 18 employees. We have 3 soil scientists, 2 field teams, 2 GIS employees, and 5 laboratory assistants. Some of the soil analysis that we do is soil chemistry analysis. So we look at all your macronutrients, phosphates, pH of the soil, soil acidity, and then also micronutrients. And then soil physics that we do is a 3-fraction, bulk density, and sodium adsorption ratio. We also do fertility recommendations, which is independent, so we aren't linked to any fertilizer companies, but we do give you recommendations to places that you can get your fertilizers from. And then we also do physical recommendations and water analysis for irrigation purposes. We have different departments in Van's lab, so that was just the laboratory part. We also have the EMI technology where we go out and do scans. We also help farmers with ultra-precision farming, and then we also do spatial mapping with QGIS. We have a soil science department where our soil scientists look at recommendations. They do recommendations for farmers, they do product testing, and we also assist with environmental studies to help mines with rehabilitation. Then we also have the irrigation scheduling department, which is one of the main reasons why Wim is here today as well with IRRIWatch. Okay, Van's lab also takes part in PT schemes, proficient testing schemes with AgriLoasa. We also have in-house accuracy measurements, and we're currently starting with our SANA's accreditation at the moment, so it takes quite a while. But this is all to ensure that we have accurate results, and we supply our clients with results that are accurate and precise. What makes Van's lab different or unique? So we take core samples, which is an in situ sample or a genuine representation of the soil in the field. On these samples, we measure bulk density, saturation point, drained upper limits, and saturated hydraulic conductivity. And yes, this is commercially available to clients. So there is labs that does these types of analysis, but it's not commercially available to clients. So you'll wait a long time for your results. But here at Van's Lab, we do it in 2-3 weeks. Okay, who can take soil samples? So we usually send out our field teams. They can take samples for you guys. We do specialized sampling, zone sampling, grid sampling, and just normal sampling as well. You can also get your advisors to send in samples, or you yourself can take samples as well. If you take your own samples, just make sure that you are not contaminating the soil samples and that you take an accurate representation of the field that you want to analyze. Yes, to most people, it's just dirt. To the farmer, it's potential. To those who work in hectares and not hours, we thank you.
Great, thanks, Lindy. So now you guys have a bit of background on Van's Lab. It's not something that started yesterday. We've been coming for quite a while. So yeah, please speak to us. And if you guys need a new lab, we're on your front stoop here. We're close. You don't need to send them the samples to Brookside. Just for the live link audience, I did receive some feedback. There's some glare on the screens. You guys can't see the slides very properly. I'm sorry for that. I will have all these slideshows on the website and then the video of the live link as well. So you guys are more than welcome to go and look at the slides afterwards if you need to recap on something. Okay, so I'm just quickly gonna sum up on the technology. I know a lot of you guys already know the technology, but there's the way everything links in. That's why we recap on that. So I'm going to go through the slides quite quickly. If you need to ask more in-depth questions, like I said, this is not a lecture, it's a discussion today. Please ask, and we can work from there. So this is just quickly our footprint, and the reason for this, I know the Western Cape guys if you guys are joining us, you are the corporates for this. Normally, when you tell them, I know we're from Bloemfontein, they're like, oh, but you don't know the Western Cape soils. But with the 3 soil scientists we have, if you're, soos hulle sê in Afrikaans, jy sout werd is, then once you stand in the profile, you'll know that soil. So we work all across the whole of South Africa, and we concentrate on the soils first. Then we bring in the crop. All right, so we go out, look at the soils, and make sure that we get optimal circumstances for the soils and for the plants to operate efficiently. So, like Lindy also mentioned, accuracy, that's what we concentrate on. So just to give a quick explanation on this, if you look at the top left-hand side, you'll see if you go and shoot or you throw darts or whatever, if you're all over the board, you have a very low precision and a very low accuracy. But once you start getting that dots together, or you have your rifle sorted out, and he's shooting a nice group, you have very high precision. But that isn't to say you're hitting your mark yet. So that's where we come in with our calibration methods and everything to make sure we get accurate. We want to know what we work with. So when we talk about accurate farming, we're not downgrading or dismissing precision farming at all. It's actually a part of what we do. It's just we make sure that we hit the mark and we know we work with what we want to work with. So I haven't done this slideshow in quite a while, so it looks strange to me as well. Okay, so with this method, we can either be preventive or curative. So the reason why I'm saying this as well is a lot of guys, when we talk to them, say, yes, but I already planted my orchard. How am I going to change anything now if I see I have to? There is ways. So we can do this preventive. So we can, if you want to establish a new orchard or a new development, it's very nice to do this and to make sure your planning is very accurate. Or if you already have established fields, to know that we can sort out the problems that have accumulated over years in that area. So if you already established, there's a lot of guys that think that this isn't then for them, but it is. It's through the bank for all types of farming activities or where you are in your process. Okay, so Van's Lab, we have a 6D approach. My dad has a very interesting saying that every fly has his heap, elke brommer het sy hoopie. And everyone just wants to concentrate on that. So if you get to the chemical guys, they're going to fix everything with chemicals. If you get to the fertilizer guys, they're going to fix everything with fertilizer. You understand what I mean? They just concentrate on their domain. We say, no, that's not right. You have to have a holistic approach. So we have a 6D approach. And we're not saying we're going to help you. We're going to try to help you, but we're going to be the experts in all 6 of those, let's call it, factors that you have to encounter or look at. But we go and in every place where we work, we pull in then the experts with regards to crop, with regards to irrigation, fertilizer, that works in that area. So we really extend and work with everyone within the area. So if we come and work with you, it's not I want to steal someone's clients. So that's why we work with a lot of service providers as well. Okay, so when I talk about a 6D approach, it's 6 drawers. That just imagine yourself a bedside drawer or your cupboard or whatever. 6 drawers that you have to open and really look into depth into each one of those to see what's going on. So the first one is your climate, and well, we can feel the weather today. It's cold. Yesterday was hot. Today it's cold. But when we talk about climate, it's over years. It comes with a long history. All right, so the first one is climate. We normally don't do that for farmers. You guys have been on the farms for quite a while. The crops are normally established within an area. So this is more when you come with new crops into areas and you really want to see if the climate's going to support that crop and you're going to have efficient production. So, but we do that for, like Lindy mentioned, our environmental studies and all that type of stuff. So farmers, normally that's a side, but we can do that for farmers as well. So the second one is topography. Another thing not very much people look at. So we are a soil lab, and we tell you, listen here, second on the list, topography. You really have to look at that, because that incorporates with soil and your management and all other aspects. So the second one, topography, and that's where we start. We really measure that in depth. So the systems that we use, you're more than welcome to afterwards look at them. They're at the back. We have up to a 4 centimeter in elevation accuracy. So we really look at topography in depth. Then we get to the soil. And when we get to the soil, we don't just concentrate on that top part. Normally the guys from fertilizer side, they concentrate on that top 150, 200 millimeters. We say no, you have to look at your whole profile. And just a quick example, in the Western Cape, when we got there, when we started working there, once again the Western Cape. Once we started working there, the guys, when we said, hey, listen here, we look at the whole profile, and that profile goes up to 1.5. They're like, oh no, I only farm in this top part. You're wasting your time and my money. And 95% of the problems that we occurred there was below the space they normally look at, and that kicked back every time. So we say no, we really have to look at the whole profile, and we divide that profile in 3 layers. We have our, I'm calling it here your A, B, and C horizon, but it's not really your horizon, because your C is going to be your parent material. I can actually call that layers, my A, B, and C layers. So the first layer is the top 300. That's where we concentrate on your fertilizers and all that stuff, your chemical part, and then your second layer is up to 750 millimeters, and then the third one goes up to 1.5 meters, and that's your production profile. And then the sixth one is where we were very glad when we yes, where's my English there? My airtime is already done. I haven't even started. Where we met Wim, and we were very excited about the technology that he uses, because Leon, like he said, he's been in the industry for a very long time, and for the first time he feels like here's something we can use to really optimally manage our crops. And that's a moneymaker. That's at end of the day what everything is about anyway. So that's a moneymaker. You want to be optimal with that. So that's a 6D. So next time someone comes to the farm and tries to only sell you that top part, ask him, but how does that incorporate with what's going on deeper in? And how does that, in the end of the day, affect the plant? All right, so the technology that we use is the EM38. You will also see it there at the back. It's a very small, light machine, electromagnetic induction. Leon's been working with it for, like I said, 15 years within the varsity. We've been 5.5 years commercial now. So we really have a lot of experience on this. And in America, I had the comment this morning that it's being used internationally a lot. But through the research that we did, or I say that Leon did mostly, but I joined him the last last few years of his research. We really developed methods to look at more than what the EM is just invented or made for, and we'll get to that. But it's the EM38, and what really changed over the past 15 years, the EM technology stayed the same, maybe a coil more, you can get more depths, but what really changed is the GPS systems that you use with that. So in our research, we saw that using a cheap, inaccurate GPS that's 5, 10, maybe 15 meters accurate, you can't get the answers that you want, because I'm taking a reading here, and especially with salts, you know that can change within a few meters. So if I take a reading here, and tomorrow I want to come and take a sample, and I'm 10 or 15 meters away, I'm not going to get a very good answer or calibration on my data. Okay, so that's the GPSs. We really do not skimp on that. We invest a lot on our GPSs to make sure that the answers we can give you guys is really what we're working with. And that's what I said this morning as well, working towards that accuracy. So just the basic principle on the electromagnetic induction technology. If you have a stagnant magnet or a normal magnet, it doesn't have a lot of function. The wives put stuff up on the fridge with the magnets, or children play with it, or whatever. It's not a lot of functions that you can get out of that magnet. But if you have a coil and you put a stream through it, you generate a electromagnetic field. And that field you can manipulate. You can make it stronger, weaker, to get bigger or smaller readings, and you can get data out of that reading. So that's the basic principle that we work on. And it's not something that I grabbed out of space here and now I want to come and push it down your throats. You work with it every day. It's just that we don't really think about it. And this is just a few examples that you guys see here on electromagnetic technology. So it isn't something that you're not familiar with. The most advanced example of this is your CAT scans. And what does a CAT scan do? It sends out that electromagnetic field into the tissue, and the machine picks up how that tissue gelei. Sien, daar's my Engels heeltemal klaar. Conducts. There you go. So that machine picks up how the tissue conducts that electromagnetic wave. So in the CAT scan, it just breaks up the tissue in very, very small layers, and it shows you how everything conducts, but it can never tell you what it is. So I can just go and delineate and see where something is that conducts differently. But a doctor still has to go and take a sample and analyze that for what is actually going on there. Is it cancer? Is it something that we don't have to worry about? But you still have to go and take a sample. And that's the big thing for me with the whole EM. There is 2 or 3 other companies in South Africa working with the EM as well, but they just scan. And then they want to come and give you your answers based on that. And you can't do that. And the reason for that is the EM is designed for 3 main things. That's water, salts, and your textures. So if you get a reading, which one of those 3 really influenced that reading that I'm getting, or what combination of the 3? So you see why I say you can't just go and scan and think, now I'm going to give you an answer. You really have to go and sample and analyze, what am I working with? Setting that scope, making sure I'm hitting my target. I'm not going to shoot that kudu miss very precisely. I'm setting my scope in. Okay, so how does it work? When you send out that electromagnetic wave, you can see there at the back is the transmitter. It transmits the signal. The soil influences that electromagnetic wave. It creates a secondary wave, and that wave is received back by the EM. And that's how we get our data. And this happens at a speed of 1,600 kilometers per second. So that's why we can move. You can see there at the back, we move with a quad bike over the field. You don't have to be stagnant. You don't have to stand still. I know with some of the older technology, that was one of the requirements, but you can move over a field. So we can very productively scan a field. Okay, so once that signal hits, or that magnetic wave hits a soil, what influences it? Okay, so it's conduction, like I said. So if you have soil particles, there where the soil particles connect or touch each other. Yes, see, rara. Maybe I should grab a beer here at the back, my tongue can loosen up. So there where the soils touch each other, that's where your stream will conduct. Okay, so think about a vase. If you take it, fill it up with tennis balls, and you take that same vase, you fill it up with marbles. With the marbles, you have a lot more connection areas than with the tennis balls. So that's the first thing, is your textures. The smaller the texture, the smaller the particles, the better the conduction. So sand, salt, and clay. That's one of the main things as well, what the EM is built for. And then if you have in your voids, your areas, your spaces between the particles, you have moisture there, or dilution, water. It also increases the conductivity. So you can pick up water very well with the EM as well. And then if you have salts in your dilution, it's also increases the conduction. So salts is witbrak, swartbrak, and of course your fertility as well. That's just the good salts, the salts that you want there, the plants use. So that's the three main things. And like I said earlier, with Leon's research, and there's some of his students here as well, I must give credit to them as well. He developed ways to get more out of the EM. Okay, so like I said, once you get a reading, it's up to 1.5 meters, 1.5 meters deep. That's the effective depth. You can go a bit deeper, but that's effective depth, and that was what the EM was made for. And you have that meter-long reading, and then about 500 millimeters. It's actually 750, but just to simplify, 500 millimeters on each side of it. So you have a 1.5 cubic meter reading if you take a sample with the EM. Okay, so let's just quickly compare this. And once again, I'm not degrading or dismissing anything that you do within the field. Anything that you do is better than nothing. But if you take this and compare it with a grid sampling, if you do grid sampling and you auger, you have that 75 millimeters, 1 per hectare. So you have that 75 millimeters, that 150 or 200 deep, representing, how much is a hectare? 10,000 square meters. All right. So with the EM, once you start scanning with this, we have a transect on irrigation of 10 meters, dryland 20 meters. But let's work on the irrigation. You have 1.5 cubic meter reading every 40 square meters. So we take a reading every 3 to 4 meters, 10 meters apart. So it's 1 cubic meter reading every 40 square meters. And that's also why Lindy talked about precision, ultra precision way of measuring. And normally when I say this, the guys, sorry for my French now, oh, fuck, ek's nog eers op precisie nie. Nou wil jy al ultra precisie toe gaan. That's not the case. You can really use this data from the guy that farms your most primitive way of farming to the guy that does everything variable. You can use this data. Just a quick example, we had one client, he didn't have any variable application equipment or nothing. When we did this, he somewhere took 20-liter cans, marked out the zones that we had, and told his workers, listen here, this side of the drums, you do this application. If you're done, you come back, recalibrate, and then that side we do the other application. So really, don't get a big fright and say, oh, now I'm going to have to buy everything variable. That's not the case. We can really implement this throughout. Okay, so the practical side, so there's the EM38, and then it goes into a a plastic car at the back. So electromagnetic induction, remember if you have anything metal around it, that influences your readings that you get. So you'll see the plastic car there at the back. It's a certain distance behind the quad bike to make sure that that doesn't influence our readings. And it has to be a certain distance from the soil as well to get accurate readings. So there's the card, and then like you see there, the GPS. And that's, like I said, where the main changes came in, the accuracy of the GPS systems that we use. All right, so once we scan, you'll see this photo here at the bottom. If we do scan vineyards or orchards or whatever, we move that card to the right-hand side and we scan as close as possible, because that's where you're doing everything. You're putting your water down there, you're putting your fertilizer down there. That's where everything happens. So we make sure we scan where you work. It doesn't help you scan an interrow and it doesn't represent what's going on where the tree is. Okay, so on the right-hand picture, you'll see it looks like a lot of lines over the field, but if you go and zoom in, you'll see it's actually data points. And that's what I said, that's that every 3 to 4 meters we have a 1.5 cubic meter data point. All right, so there you see that 140 hectares where you would have had, let's say, okay, it's irrigation, 1 per hectare. If you would have had 140 samples, in this case, yes, I can't remember, I think you had more closer to like 40,000 readings over that whole area. So instead of 1 per 10,000 square meters, we had 1 for every 40 square meters. Okay, so you can really see what's going on in your field. That small little changes. We get to a lot of guys and then they say, oh, but is this thing going to pick up my my changes? Because, yeah, I have clays, there's sandy soils, and just a bit further you get loamy soils again, and it changes very quickly. But is questioning me on this method, but he's happy with the 1 every hectare type of grid sampling method. So you can really get all that changes, and that's the food of the EM. It's that change. That's what really makes it pop out. Okay, so like I said, first of all, we start with the topography. We go and look at the, okay, sorry, so this was just quickly the technology and how it works, just to show you guys that it's not something unfamiliar. It's not something new that I want to push down your throats. It's not something I grab from space. It's out of this world. It's really something that we actually work with. It's just the way in which we work with it. Okay, so we start with the project. Once we scanned, we go and look at the whole surrounding area. So you will see the 2 farms here, the yellow lined and the red lined there, outlined. We have the 2 farms, but we go and look at what's the surroundings influences on that farm. Like Leon always said, you chose your wicket, now you have to cover it. Okay, so how's the outside going to influence my farm? And a lot of farms we were on in the past, we could show out a lot of the big problems just by the surrounding factors that the farmers never even considered. All right, so we look at the topography around the farm and how that influences the farm, and then we go and look at that up to 4 centimeter accurate data that we measured. So this, the second thing is the slope map. So how's that going to affect you, your operations, your plants, your water distribution, all that stuff. So that slope maps, infield, your channel networks, where's the water going to accumulate if you do get a heavy rain shower, and where do you have to really go in and prepare for runoff of your fields or cover for runoff, whatever, and then your aspect map. So this comes in especially with the more intensive guys like your vineyards and stuff. Which cultivar do I plant on which aspect? I have a bit more cold units and heat units, and Lucas, I'm sure you will agree with me from Retondo Walnuts that had a big effect on their operations as well. So where do I plant which cultivar? Do I want something to be in production earlier or later, or I want to plan my operations. I don't want everything to be in production at the same time, because then there's a massive load of work or operations that needs to be done, and then for a while, and then you're quiet again. You want to spread that out and make sure you hit the markets on the right times, and make sure that your operations flows nicely and all of that. Okay, so that's also a very, very big thing to look at that a lot of people dismiss. Sorry, just thinking about it now. And the guy spoke French again, but I won't repeat him. We had a client in the Northern Cape that we scanned, and he never considered topography as or the aspect as a big part in his production, and he produced maize, mealies. And he never got this reading beforehand. It's one of the service providers that we work with. He convinced him to do this, to do his, that guy installed drainage. So to do his drainage design better, he wanted this data. And when we represented this to him, he's like, my French word, that's where my production changes. There was like a straight line through the field. That's where my production changes, and I don't know why. And he didn't know what map that was. So the map just came up, and that was his first comment. And then we said, well, you never considered topography to be a factor in your production. And he was always overspending, over-investing in that area to get the production the same as the other side. And he would never succeed in that. Okay, so there alone, we could save him a lot of input costs. All right, so then we get to the soil, and I think that's where we want to be today. So that's spatial management of soil. So when the EM takes a reading, it takes it throughout the whole profile, okay, from top of the ground up to 1,500 millimeters. So that is your general card that you get, your EM card. So you'll see there is a red part, and that immediately draws your attention. All right, but if you go and zoom in, you can see there's a lot of spots and changes, even in those greener areas. And we really want to know what's going on there. Once again, the ultra precision. Not knowing just per hectare, we want to know every square meter what's going on. So without ground truthing, like I said earlier, the doctor still has to go and take a sample. This card doesn't mean a lot. It gives you a good idea on the general conductivity, but what is it now? Remember I said it can be textures, it can be water, it can be salts, or it can be a combination of the three. All right, just quickly, another thing that influences this, if you have compaction, remember that soil is compressed. So it also has a lot more contact areas. So you're also going to get a higher reading. You see what I mean? You can't just go and scan and say, here's your answer. You really need to go and take samples. So what we do then, like I said, with the precision and accuracy, the EM is very precise. If I go and rescan that area in a year or 2 years and nothing big happened, the guy didn't change, had big changes, I'm going to get the same picture. But the readings that I get there in the legend, on the left-hand side, is relative. It's relative to the day, it's relative to the time of year, it's relative to sun floods. Remember electromagnetic induction, even your sun floods influences that reading. So that's why we have a certain calibration point, and we make sure that even year on year, we work with soil data. So I can go and scan that area again, and let's see there, the lowest is that 8.28 millisiemens. Next time I can get it 5 or 20. Like I said, that influence. So you can't just have a scan and a reading and interpret that to analysis. Okay, so what we do then is we go and determine sample points. So it depends on how big your area is. It's going to be 6, 8, 12, 20, and then from there on it depends on the hectares, but it depends on how big your area is. We're going to have sample points, and that sample points will represent your highest readings, your lowest readings, and everything in between. So we can get a good calibration model. We want to tell the EM, listen here, this is what a high reading means, this is what a low reading means, and everything in between. And then we, like I said, we build that calibration model, and then we go and calibrate that 40,000 or 50,000 data points that we have over the field. And we also tell you, let me ask you guys this first. Have you ever, with a grid sampling analysis, received any stats on the accuracy of that map? Just maybe a quick indication. You won't. First of all, you need, I think it's at least 140, Leon, help me, 140 samples just to get a good statistical model. So you'll never get stats with that. But if that guy comes and gives you that lines, you believe him, that line is that line. But what we do is I'm going to tell you how accurate is that line. Is that line really that line? If it's something simple, a dynamic property I'm managing, I'm going to work with that. But if it's something permanent and I have to go install drainage or divide my blocks or whatever, and my stats maybe isn't what I wanted it, I'm just going to go and confirm, is that line really that line? Okay, so what we get with and what we concentrate on is that physical properties that Lindy also mentioned. With that core sample that we take, you can see there the back is some of the sampling equipment, but that's what we really want to get to. So we concentrate heavily on the soil physics, okay, and the incorporation of soil physics with your soil fertility. So if you see that, I'm showing with a pointer here, as if that's going to show on yours. I don't think you will. So if you see that diagram, that circle, take that as 100%, that cake or whatever, it's 100%. Now this is an ideal representation. 50% will be solids, sand, salt, and clay, and your organic material. This isn't what it's going to look like in every field. I don't think we ever had a ideal soil before. So that's going to change. But that's what we look at. We look at what part of the volume that you're working with is actually soil, sand, salt, and clay, and what part is your pores. And then we go and look at the functionality of those pores. Because let's take this building, for instance. I have the bricks. That's my texture. But what I'm interested in is the structure. So if I go and put that bricks on a heap, what am I going to do with this? There's no functionality. There's maybe a few rats or insects or whatever that's going to live in there. But it doesn't have a lot of functionality. But once I go and I stack those bricks in an order, I create a kitchen and a living room and my bedroom and a bathroom. And each of those spaces have a different function. Now that's the same in the soil. So go and look at the solids, go and look at the pores or that spaces, and then we go and look at the functionality of those pores. So if you look at the blue part there, that's your bigger pores, your macro pores. So what's the function of those pores? Everything that needs to happen fast happens there. If you want to get water, if you irrigate and you want to get water down in your profile, that's where it's going to move. Air movement happens in those pores. Heat movement, CO2 exchange, all of that. That's everything that needs to happen fast happens in those pores. Then if you look at the green part there, that's your storage pores. So without that, we wouldn't have been able to farm. Water would have just ran through. So that's your smaller pores that holds the water back at a greater strength than what gravity pulls the water down with. All right, so, and that's what the plant used. That's your water available of, your water capacity or your tank. And then if you look at the red part, that's your really, really small pores. That's your clays that holds the water at a higher strength than what your plant can subtract it. But all your chemical exchanges, that's where that happens, that chemical exchange between the solids and the dilution. Because remember, plants can only take up what's in dilution. It can't get what's fixed to the soils. All right, so just once again, go and look at your bulk density. What's the importance of your bulk density? Can anyone just quick comment? What's the importance of bulk density on any operations? So if you go and you take a sample and you analyze for your fertilizer, your recommendations that you want to go put down, you get your analysis in milligram per kilogram. I have, let's say, P. I have 10 milligram per kilogram P. But what does that mean? That's a concentration. How many kilograms of soil do I actually have in that volume that I'm working with? All right, and what we found in the industry is that amount can be up to 30% out. All right, so if you are 30% out and you're saying you're doing precision farming, where are you? Okay, you understand what I mean? So you really need to know what's the volume or what's the amount of soil, the kilograms of soil that I'm working with in the volume that I have. So that top 300 millimeters. All right, so I can go and determine how much fertilizer do I need to put down. Once again, Western Cape. Yes, I'm referring a lot to them today. I haven't seen them in a while, so it looks like I'm missing them. They have a lot of stones in their soils. And that doesn't partake in the whole chemistry transactions and whatever needs to happen. Then they come back with a reading, a high concentration, milligrams per kilograms, and they're like, oh no, I'm fine. But once you go and recalculate that to the amount that you have in your soil, they're like, oh, what, is that all I have? So what we work with and why we measure this is, I want to tell you at the end of the day, listen here, your plant is going to use 20 kilograms per hectare of P, and you have 10 kilograms in your soil. Go and add what you need. Or you have 50 kilograms. Why do you want to add? Especially in years like these where fertilizers are so expensive. Why do you want to go and add something that you don't need? Oh, well, you need to have a buffer, but in years like this, we're not going to build that buffer. We're going to use that buffer that we build it over many years. Okay, so that's the importance of that. So if I come and I take a sample with an auger, I break up my whole structure. My whole structure is loose, and the bulk density isn't the same anymore. Once again, that's why we take the core samples. All right, so once we measured all that, we go and spatially represent this with the maps. And that's where the GIS office comes in. We spatially represent this to the farmer or to the client and say, listen here, this is what it looks like spatially. This part of the field, I will have some problems, this side maybe not. And you can see, is that screen going to stand? Okay. You can see in the left-hand corner up there, there's a green mark there. That doesn't mean I don't have a problem with that. You need to go and look at the legend for that. But that just says, hey, listen here, my stats is great. Okay, so the stats I have for that specific analysis